This is theory question 11 in WAEC of 2022. This is the A part. The exterior angles of a polygon are 42 degrees, 38 degrees, 57 degrees, x degrees, x plus y degrees, 2x minus 15 degrees, 3x minus y degrees. If x is 7 degrees less than y, find the values of x and y. First, we are told that all of these angles are exterior angles of a polygon. Now, the number of angles here will tell us the kind of polygon we are dealing with. We've got 1, 2, 3, 4, 5, 6, 7. So this polygon has 7 sides. This tells us that this polygon is a heptagon. Irrespective of the number of sides of a polygon, the sum of exterior angles will always be 360. The sum of the interior angles is what changes with respect to the number of sides. But for the exterior angles, irrespective of the number of sides, the sum will always be 360 degrees. Thus, if we add all 7 angles, 42 degrees, if we add that to 38 degrees, then 57, then x degree, then x plus y, then 2x minus 15 degrees, and the final one, 3x minus y, we should get 360 degrees. And this is because the sum of the exterior angles of a polygon, irrespective of the number of sides, is 360 degrees. Now we need to add 42 and 38 and 57, then take away 15. That's going to give us 122. Then the letters, x plus x is 2x, plus 2x, that's 4x, plus 3x, that's 7x. Then the y, we've got just y and minus y, so y is gone. This is equal to 360 degrees. We're going to solve this equation. This is equal to 360 minus 122. We've got a 7x on the left. 360 minus 122 is equal to 238. Dividing both sides by 7, we realize that x is equal to 34. This is the value of x. Our intention is to obtain the values of x and y. Thus, we've obtained the value of x. The next is to obtain the value of y. And we are going to be relying on this short statement here that x is 7 less than y. The implication of that is that y is equal to x plus 7. So this is what it means for x to be 7 less than y. Having obtained the value of x, that's 34 degrees, y is just going to be 34 plus 7, and this is equal to 41. These are the values of x and y. Here is the B part. We are told that in the diagram, O is the center of the circle XYZ. Angle ZXO is 34 degrees, and angle XOY is 146 degrees. Find the value of angle OYZ. The angle OYZ, this is OYZ. I'm just going to mark it here. I could even call it alpha to make it easy for me. So since O is the center of the circle, then it's obvious that this line OZ is a radius because it's a line from the center to the circumference. Similarly, OY is also a radius. It's from the center to the circumference. And OX is also a radius because it's a line drawn from the center to the circumference. And since we are dealing with the same circle, the radii would always be the same. Thus, I'm going to have one stroke each to show that all 3 lines are the same. Now, the implication of this is that this triangle here, OXZ, I'm going to shade it in green. This triangle OXZ is isosceles. The triangle OXZ is isosceles because 2 of its sides are equal. And we know that in an isosceles triangle, the base angles are also equal. Of course, the base angles are the angles that are outside of the included angle between the 2 equal sides. So that tells us that this angle here, OXZ, the angle at x, is going to be equal to OZX. because they are the base angles of the isosceles triangle. Thus, since OXZ is 34 degrees, OZX is also going to be 34 degrees. So I'm just going to do this 34. Okay, perfect. Looking at the triangle on the right here, OZY, we would also see that the triangle is also an isosceles triangle. So I'm going to write triangle OYZ is also isosceles because, of course, two of its sides are equal. And as I mentioned in triangle OXZ, the base angles would also be equal. Now, how do we identify the base angles? As usual, this is the angle that's included between the two equal sides. That leaves the two remaining angles as the base angles. Therefore, we can say that the angle OYZ, the angle at Y right here, is equal to the angle at Z, that's OZY. And since I already labeled OYZ as alpha, I'm just going to have alpha here. So I'm going to label this alpha. Okay, this is looking so good. Now we are going to rely on one of the circle theorems. Since O is the center of the circle, we can see that the angle XOY, which is 146, is the angle that this arc, XY, subtends at the center. So XOY, which is 146 degrees, is the angle that this arc right here subtends at the center. And we know that the angle subtended by an arc at the center is twice that which is subtends at the circumference. So if we do this, we're going to see that this arc, this is the arc XY right here. Now it subtends this angle 146 at the center. This same arc subtends another angle here at the circumference. Now the relationship between these two angles is that the angle at the center, which this arc subtends at the center, is always twice that which is subtends at the circumference. So XOY is going to be equal to twice XZY. And we know what XZY is. That's 34 plus alpha. So this is going to be 2 times 34 plus alpha. Solving this equation, I'm just going to divide both sides by 2. 146 divided by 2 is going to give me 73. So I've got 73 equals 34 plus alpha. Collecting like terms, this is going to be 73 minus 34. And this gives 39 degrees. So the value of alpha is 39 degrees. The next thing is just going to be to recall that the angle OYZ was well represented by alpha. Therefore, the angle OYZ is 39 degrees. Thank you for watching this video. If you find it useful, kindly like it by giving it a thumbs up. Share to your friends and colleagues on social media. Don't forget to drop a comment and click on the subscribed icon. To get notified when I upload new videos, kindly click on the all, that's the dark bell button on the subscribed icon. Thank you for seeing it once again. See you in the next video.